the cause and cure of bruxing and clinching. These are issues that cause a lot of concern to quite a lot of people, and I think it's getting worse. These cause problems like headaches, jaw joint problems, and even dental wear. And there's a lot of discussion within dentistry about why these problems are caused, and a lot of interesting treatments. The treatments seem to be splints. People put splints, whether they are hard splints, like we have up on the top diagram, or soft splints down on the bottom right hand side. And the hard splints are often finely adjusted, as you can see down on the bottom left, using basically carbon paper, where you bite together. You can then make marks on the splint where the teeth touch the splint, and they can be ground so that you can get sort of balances between the jaws, the upper jaw or lower jaw, doesn't matter which side the splint goes, can have the teeth adjusted so that they meet the splint in a smooth way so you can move well. Some people say a smooth way with non-working side or working side contacts, or there's a canine guidance, group function. There's lots of different ideas behind how you can adjust these splints to correct the sort of, or improve the habits or the stimulus that lead to bruxism. There's a great deal of disagreement. My concern about a lot of these appliances is, of course, that they can occupy tongue space. And some of the soft ones, they can actually almost encourage chewing. You know, put something that is chewy between the teeth of a chewer and they may well chew on it, and that could be counterproductive. So the suggestion is that we're overworking our chewing muscles, and the recommendations are often to hold the teeth apart. Whether that relates to a splint or not, there's some debate on that. Sometimes you have these reflex liberating splints where you overstimulate one or two of the teeth, usually the lower front small teeth, so they surpass their load threshold, which I'll mention later, so that sends a reflex back to cause jaw opening, or at least a reduction in the jaw closing. But people are asked to avoid holding their teeth in contact, and of course avoid chewing gum or excessive use of their jaw muscles. And I guess if you've got problems and you've got damage in the jaw joints, that I guess is not a bad idea, but that's not normal state of affairs. So that's dealing with a pathological situation. What should we normally do, particularly if we don't have problems? Well, when we're talking about the disuse theories, so we're saying we're overusing our chewing muscles, it's interesting to reflect back to see what our ancestors did. It's important to remember that we've been anatomical humans for 220,000 years, and there's no evidence, and also when you look at indigenous populations, there's no reported symptoms of clenching or bruxing. It seems to be a modern problem. Now, it does interest me that indigenous and ancient man had a great deal of wear. They wore their teeth down heavily. Not one or two of them, but they all did that. I mean, here's an image of a relatively modern Aboriginal and some teeth from a preserved skull. Both of them have a great deal of wear on them. And it's interesting because there's a whole science that is formed relating to what we would term as attrition. Attrition is tooth on tooth wear. And it's interesting because, of course, we know approximately when the teeth should erupt. So your first lower molar is coming up soon after 6 years old, then your 12-year-old molar coming up at 12-year-old, and your wisdom tooth would come up around 18. In historical societies, it was fairly consistently around 18. I know people don't tend to be very delayed, or they don't come up at all in modern era. But when you had this fairly consistent pattern where the 6-year-old molar arrived at 6, the 12-year-old molar arrived at 12, and the wisdom tooth arrived at 18, you could use the difference between the wear on these individual teeth to work out roughly how old the individual was. And it seemed fairly consistent, and as mentioned by Brothwell here, it was unfortunate that the rates of wear were fairly consistent between the Neolithic to the medieval times. So right up to the medieval times, this seems to have been quite a normal pattern, and it was used to measure the age of skulls. And an interesting quote, I can't find the exact source of this, but I remember someone saying this quote to me. It says, "It was not uncommon for the lower first molar, tooth number 6, or the 6-year-old molar, same tooth, to break into its separate roots in the middle of the 4th decade of life." So that's where the tooth has worn so far that the roots, you reach the root level, you wear through the tooth till you've only got the 3 roots or 2 roots in the lower present. Now that's a huge amount of wear, that's a vast amount of wear, but basically it's clear to say that our ancestors had a lot of wear, a really large amount of wear, and they didn't get bruxism or clenching to our knowledge. So, is clenching and bruxism related to overactivity of the muscles? Well, possibly. But I think it's a little bit more complex, and as with many things, I don't think anyone out there is completely wrong. It's just a little bit more complex, and sometimes you need to look at the slightly more complex answer. It's interested me that all skeletal muscles that cross a joint are arranged in antagonistic pairs or groups. All of them. You don't have muscles that just work on one side of a joint. It wouldn't work. You would have no control. Of course, the classic example is the biceps and your triceps. It interests me that, of course, I can use my biceps and triceps, and I can move my arm up, because as I do that, I'm clearly using my bicep, but the triceps is also working. It's not that this muscle isn't being used at all. It's controlling it. It's slowing down and regulating the action of my bicep. So both muscles work there in a nice antagonism, and of course they'll work in an antagonism in this orientation, and they'll work in antagonism in this orientation. And by and large, apart from the physical weight of my forearm, I don't really perceive any difference. It seems more or less the same to me. And that's a lot of this is because I've got some neural control going on. It's going on at the level of my spine, and that's really controlling, you know, not only the regulation, but also the overactivity, underactivity. You know, it's controlling the muscles in such a way that I don't really think about what I'm doing. I'm just saying, move out, move back, move out, move back, move out, move back, and it works it out for me. There's no point in bothering my higher centers with this sort of thing. It's very similar in a way to when you have a pain reflex when you burn yourself. So you touch a hot thing, the pain, well, there's no point in the pain going all the way up to your head, you thinking about it, oh yeah, it's burning, I mean, I'll be smelling barbecue by the time that happens. No, you want an instantaneous reflex reaction, so you put your finger or hand or whatever's being burnt straight away from the source, so that you protect yourself. I mean, you need that. That's a reflex that goes on. Now, it interests me. I remember someone telling me that dinosaurs had many brains. Now, that's not entirely true. They only have one place they think in. But of course, a lot of this local regulation can be farmed out. It can be housed further down their body. And of course, when you've got something quite that long, it's a sensible thing to do, because the time lag of coming up to your brain and all the way back again would cause you lots of problems. In fact, it could also almost occur sort of levels of resonance going on within the system that could be quite damaging. So it is interesting that people have identified the potential of hindbrains spaced about the by the limbs in the spinal cord area of some dinosaurs. Now, I've heard many people say that the masseter is the strongest muscle in the body. Now, weight for weight, any cubic millimetre of muscle is the same as any other cubic millimetre of muscle, by and large. I mean, there are slightly different types of muscles, but if we're talking about voluntary striated muscle, they're all about the same. Now, there are different orientations, and here it describes 3 of the classical types of levers. Now, most muscles work as a class 1 lever. So, for example, my elbow, the tricep pulls on the bit of my elbow that's this side of the joint, and the force is produced at some distance on the other side of the joint, hinging around in the centre of the joint, like a classic class 1 lever working at a disadvantage in this situation. Now, of course, the masseter is different. The masseter is working at it was a slight disadvantage, but not nearly such a disadvantage. So if we look at these different types of muscles, you've got the knee, where the quadriceps works on about a 25-to-1 disadvantage, which gives more range but less force. Of course, the biggest muscle in your body, the glutes, is working there across your hip at about a 10-to-1 disadvantage, which gives it less range, but of course some enormous power. You know, you can wear a big rucksack, or you can carry someone else, and you can go from a squat and you can stand up. That's your glutes. That's your 10-to-1 advantage or disadvantage on that lever arm.